Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on measurements and uncertainties from October-November 2021 paper 2-1. The main purpose of this video is not to give you answers for these questions. In fact, the main goal of this video is to teach you how to answer this type of problems. In today's lesson, we are looking at October-November 2020 one paper to one, and total time for this exam is 1 hour and 15 minutes. You need to answer all the questions in this paper, and the total mark for this paper is 60. On the second page of exam paper, you can find values of some important constants. Let me highlight some constant you need for AS physics exam. The first one is the speed of light. The speed of light is very important because in exam often they will ask you to calculate the frequency of electromagnetic waves. So for that purpose you need speed of light. Means the speed of electromagnetic waves in air are in free space, and speed of electromagnetic waves in air are in free space is almost same. So then simply you can use V is equal to F lambda and you can calculate frequency if the wavelength is given to you. It's a very common question, so you have to be clear about this one. And the second important constant is the charge on single electron, and this is also called elementary charge. Means the charge on proton, charge on electron is the same. So we call this is elementary charge because this is the smallest possible charge on any particle. Means independent particle can exist independently, so this is the elementary charge. Quark has charge smaller than electron, but quarks do not exist individually, so that's the reason we call this is elementary charge. The second constant maybe you need, that is 1 joule. So this is 1 AMU, means atomic mass unit, and this is about the mass of proton. And next one is the mass of rest mass of electron. So this is also very important, you will need for some calculations. And the mass of proton is also very important in exam. If they ask you to use mass of proton, this one you have to use. Last important one can be the G, value of G. At AS level in paper 2 you have to use G is equal to 9.81, not 10. In the final CIE exam you will also find a list of important formulae. These are some basic formulae. If you can remember them is wonderful. Otherwise, they will be given to you in your final CIE exam. The first formula is for uniformly accelerated motion. It simply means that you can only use this formula if acceleration is constant. Means A is not changing with time. You can only use this one. So this is very important point. You need to understand what is condition for this one, when you can use this. Only if A is constant. And the second important formula will be given to you is about work done by a gas. So this is work done by a gas, and this is only true, this formula is only true if the P is constant. So P is the pressure here when this is constant. So we can only use this one if the pressure of the gas is constant but volume of the gas is changing. And the next one is P is equal to rho GH. This is also important one. H, often students they confuse with this one. H is depth, it's not the height actually. So better way to say this one is depth. And the next important formula you need for AS physics is Doppler effect. So this formula, if you look at denominator, is written plus minus. So it simply means that when the source is approaching, so observed frequency will be equal to the frequency of the source times the speed of the sound divided by V minus Vs when the source is approaching. So this is when the source is approaching. This formula is only for when source is approaching. So this is very important one. You can also find observed frequency, that will be equal to frequency of the source times V speed of sound, and this is divided by V plus Vs. S is the speed of the source. So let me highlight here, in this case S is speed of source. So this is speed of source, the source. So this is for speed of source, and V here is the speed of sound. So this will be given to you, speed of sound. Fs is frequency of the source. So frequency of source, Fs. F naught here is observed frequency, means the frequency heard by observer, or simply we can say observed frequency. So this is observed frequency. Now simply you can see this is for when the source is moving away. When the source is moving away, you can use this one. But this formula is only true. Our assumption in this formula is that observer is at rest. Mean observer in this case is not moving. So observer at rest. So this formula is true for when observer is at rest. Let's move on to next one. Next important formula you need is electric current. I is equal to A N V Q. Very important one. Most of the time there will be one question about this, so you have to be very clear with this one. And the next two, resistors in series and resistors in parallel, these are very basic formulae, but they are also given to you and you need for some calculations. And that's all. These are the formulae you need for AS exam. For part A, simply we need to define density. Very simple question. So if in exam they will ask you to define density, simply you can say density is equal to mass per unit volume. So simply you can write down mass per unit volume, and that's quite enough to get 1 mark. Mass per unit volume, and this is B mark. It means it has to be in your answer. So this question has 1 B mark, means it has to be in your answer. For part D1, we need to state the name of measuring instrument suitable for making measurement of L. And L is given here with absolute uncertainty. So the best way to answer this problem can be, we can convert this one into centimeters. So L in this case is given to us. This is equal to 0.1242 meters. We can convert this one into centimeters. So simply we need to multiply with 100. So this will be equal to 12.42 centimeters. Now let's try to understand different type of instrument. The first common instrument used in lab is micrometer screw gauge. Micrometer screw gauge. We can simply write down micrometer screw gauge. So we have to understand 2 points about this one. The first thing we need to understand is that what is the maximum length we can measure with this one. The maximum length you can measure with micrometer screw gauge is 25 mm, or simply you can say this is about 2.5 centimeters, and the precision of this one is 0.01. The precision of this one is 0.01 mm, or we can simply say this is 0.00001 meter. So this is the precision of micrometer screw gauge. Next common instrument used in physics lab is vernier caliper. Next one is vernier caliper. So let me clean first of all. So the next one commonly used in physics lab is vernier caliper. Let's try to understand a little bit about vernier caliper. Vernier caliper, the maximum length we can measure with vernier caliper is about 15 centimeters, and the precision of this one, precision of vernier caliper is 0.1 mm. So this is 0.1 mm. Commonly used, we are talking about the commonly used. Even some vernier caliper, the precision is higher than this. If we convert this one into meters, so this will be equal to 0.001 meter. So this is the precision of vernier caliper. Meter rule is also one instrument commonly used in physics lab. So for meter rule, the maximum length we can measure with the help of meter rule, this is 100 centimeters, or you can say simply 1 meter. And the precision of this one is about 1 mm. So the precision of meter rule is 1 mm. If we write down this one in meters, so we can say this is 0.001. So this is the precision of meter rule. Now we have to choose the best instrument among all these. So these are 3 common instruments used in physics lab. But if we look at the vernier caliper, first of all, let's look at micrometer. We cannot use, because this can only measure up to 2.5 centimeters. So it means we cannot use this one. If we look at meter rule, the precision of meter rule is less than the precision of given data. So we cannot use meter rule. So only possible instrument we have now, this is vernier caliper, and this can measure up to 15 centimeters. That's wonderful, because this measurement is only about 12.42 centimeters. And the precision of this one is 0.0001 meter, means up to 4 decimal places if the unit is meter. So this is also true for this one. So it means we can simply write down for this one, we can use vernier caliper. So our final answer will be vernier caliper. So we can use vernier caliper. And this question has only 1 mark, and that is B 1 mark. Mean if you simply write on vernier caliper, you can also write on digital caliper. Still, you will get this mark. I hope this point is clear to you now. Next time, you can handle this type of problems very easily. For part B2, we need to determine the percentage uncertainty in the measurement of R. For R, the reading taken by instrument is given and the absolute uncertainty is given. So simply we can rewrite this one. We can simply say R in this case is given and R is equal to 0.0420 meter, and this is the reading taken by instrument, or simply you can say the measurement. And absolute uncertainty in R is given, that is 0.0004 meter. Question is asking us to calculate the percentage uncertainty in R. So first of all, let's try to understand from fractional uncertainty. So we will understand fractional uncertainty means U for uncertainty, and this is equal to absolute uncertainty. Absolute uncertainty divided by the measurement itself, or the best value of measurement if you have more than one readings. So divided by measurement. Now, if we have fractional uncertainty, we can also convert this one into percentage uncertainty. Simply, we need to multiply right side with 100. So simply, we can write down absolute uncertainty. Again, you can write down. So this is absolute uncertainty divided by measurement itself, as I mentioned before, or divided by the best value of measurement. If you have more than one measurements, or you have taken more than one readings, and this one you have to multiply by 100. So this is how you can calculate percentage uncertainty. Now let's try to calculate percentage uncertainty in R. So we can write down here percentage uncertainty in R. Simply this will be equal to delta R divided by R, and we have to multiply this with 100. Now we can simply plug in values. So delta R is 0.0004 and this is divided by 0.0420 and this is multiplied by 100. If we calculate this one, our answer will be about 1%, and this is the answer for this question. And this question has only 1 mark, and this is answer mark. If you got right answer, you will get this mark. For part C, it is given to us that density of the rock is equal to mass times R to the power of n divided by K times L. It is also given to us that n is an integer and K is a constant with no units, but you have to be very clear, some constants they have unit, but K is a constant and this constant has no units, and its magnitude is equal to 2.094. We need to use SI base units to show that n is equal to -2, or simply you can say -2. How we can answer this question? If we look at this equation, actually this is a homogeneous equation, so it simply means that units on the both sides of this one are the same. Mean the units on the left side are equal to the units on the right side. So we will use this principle and we will try to answer. So first of all, let me rewrite this one. So m times R to the power of n. R is the radius, m is the mass, K is a constant and it has no units, L is the length. K has no units, so simply we can ignore that one, so we can rewrite this. So this is m times R to the power of n simply divided by L. Now we can write down the units. SI unit for density is kg per cubic meter, and SI unit for mass is kg. SI unit for radius means for length, this is meter and its power is n, and the unit for L is m, so this is m. Now we can further simplify. We can write down this is kg and m to the power of n, but when you take this to numerator, so its power will be -1, because here is +1, here will be -1. Now we can rewrite this. So we can write down kg per cubic meter. This is equal to kg m to the power of n minus 1. Now we just need to simplify this one. So if you look at this one, you can see kg is on both sides. So simply we can cancel this one. And we left with m to the power of negative 3 is equal to m to the power of n minus 1. So simply we can say in this case minus 3, this has to be equal to n minus 1. Now simply if we further simplify this one, we can simply say n in this case will be equal to minus 2. So this is our final answer. So this is minus 2. This is what question was asking us, to show that n is equal to minus 2. The first mark is if you have written these SI units, so you will get first mark. And this is M mark, means it has to be in your answer. And the second mark is answer mark. If you have got right answer, you will get the second mark. But if you couldn't get this mark, only you write the answer, n is equal to minus 2, you will get 0 mark. For the second part, we need to calculate the percentage uncertainty in density. And the density means the formula for density is given to us. This is how we can calculate density. Density can be calculated by multiplying these quantities and dividing. So this is simply telling us quantities are multiplied and divided. So we need to simply add percentage uncertainties of these quantities to calculate percentage uncertainty in density. So let me write down what I said. I simply said that if you need to calculate the percentage uncertainty in density, this will be equal to the percentage uncertainty in M plus the percentage uncertainty in R. We will talk about exponent later, plus the percentage uncertainty in K. But K is a constant, so you can ignore that. So next one, you can say percentage uncertainty in L. So K is a constant, it has no percentage uncertainty. So the percentage uncertainty in density is simply equal to delta M divided by M, and you have to multiply this one with 100. So this is how you can write down percentage uncertainty in M plus percentage uncertainty in R. So that simply is equal to delta R, mean absolute uncertainty, divided by R, and it has to be multiplied with 100. So we will multiply this one with 100. So it has to be multiplied with 100. But you also need to understand, we have the power of this one. The power is n, and n is negative. So n is negative, we have calculated. But here you have to enter this one plus 2, because uncertainty cannot be negative. So very important point. So uncertainty cannot be negative. So it has to be plus 2, not minus 2. And next one, the percentage uncertainty in L. So this will be delta L divided by L, and we need to multiply this one with 100. Now simply we need to plug in values and we can calculate our final answer. So in this case, delta M is 0.001 divided by 1.072. We need to multiply this one with 100, plus we have 2, and delta R in this case is 0.004, and this is divided by 0.0420. We have to multiply this with 100, and plus we have delta L. Absolute uncertainty in L is 0.001 meters divided by 0.1242. We need to multiply this one with 100. And now we just need to simplify. If we simplify the first one, our answer will be 0.09%, and for the second one we have to multiply with 0.95%, and the last one is 0.08%. If we add all together, our final answer will be about 2.1%, or simply we can say 2%. And this is our final answer. This question has 3 marks. The first mark is if you have written in this form, you will get 1 mark, and this is C mark. And the second mark is if you have plugged in these values, and the last mark is answer mark. If you have got the right answer, you will get full marks. So this point is tricky one. It has to be plus 2, not minus, because uncertainties never be negative. Uncertainties are always added, not subtracted. For this part, we need to determine density with its absolute uncertainty. And it is also given to us, give your values to the appropriate number of significant figures. So we have to take care of significant figures as well. Otherwise, we will lose marks. Now let's start from density first of all. Density we need to calculate. And formula for density is given. This is equal to mass times R to the power of N divided by K times L. The M is given, so simply you can read from here. Value of M is 1.072 and the value of the radius is given. So this is radius. So simply you can write down this is 0.0420 and the power is N and the value of N is -2. And this is divided by k. K is a constant and the value of constant, it is given in the question, that is equal to 2.094. Its value is given to us and the value of L you can just read from here. So L is 0.1242. You need to use calculator and you can find the value of density. If you do calculation, so your final answer will be this. And the unit of density means SI unit is kg per cubic meter. So all the quantities are in SI units. Now the next thing what we need to do is we need to calculate absolute uncertainty. But the percentage uncertainty we have means we have delta rho by rho. The percentage uncertainty we have, that was equal to 2.1%. 2.1%. So this value we have. Now we need to calculate delta rho. So simple way is that divide right side by 100. So simply if we divide this one by 100, so this is now fractional uncertainty. If you go from percentage uncertainty to fractional uncertainty, simply you need to divide by 100. So this is divide by 100. Now we have fractional uncertainty. We need to calculate delta rho. So it simply means this is 2.1 divided by 100. We have to multiply with density. The value of density we just calculated. Just multiply with this. And our final answer in this case, this will be equal to 49 kgs per cubic meter. I mean, this is the absolute uncertainty in density. Next part, we need to write down this density with absolute uncertainty. So you can see this quantity. If you look at this one, this has 4 SF. So this has 4 SF. If you look at these quantities, this has 3 SF, this one has 4 SF, this has 4 SF, this one also has 4 SF. So this quantity has the least number of significant figures. So in our final answer, this can have least number of significant figures or one more. So we can write down this one up to 3 significant figures. So simply I can say this is 2, 3, 4, 0. So this has 3 significant figures now. So 3 SF. Absolute uncertainty, we have to write down up to 1 SF only. So this one we can simplify to 50. Now let's try to write down our final answer. So the final answer you can simply write down like this. This is 2.340 plus minus 0.050 kgs per cubic meter, and this will be multiplied with 10 to 3. So this is our final answer. This is how you can write down. Simply you can write down here. You can say this is 2340 and this is 50. Now let me explain to you how marks will be awarded. The first mark will be awarded. So this is C mark, and the second C mark you will get if you got this answer for absolute uncertainty. And the last one you will get if you have written your answer in this form. The main concept what you need to understand is how to write down quantity, mean this quantity and the absolute uncertainty. The simple way is that first of all you have to understand this absolute uncertainty, it should have 1 SF only. And the next point you need to consider is the number of decimal places. How many number of decimal places are in absolute uncertainty? Same you have to use in this measurement. So they must have the same DP. If you follow these rules, you will get full marks. Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on momentum conservation from October-November 2021 paper 2-1. I said this is a typical type of question because this type of questions are very common in past papers. And in this lesson, we will not only answer these questions, in fact, I will teach you how to answer this type of problems. For part A, simply we need to define what is momentum. And simply you can remember this one. Momentum P is equal to mv. So in your answer, you have to write down the product of mass and velocity, not the product of mass and speed. So momentum is simply product of mass and velocity. Momentum is a vector, so you have to write down product of mass and velocity, not speed. And this question has 1 mark and this is B mark. It simply means that this has to be in your answer. For part B1, we need to calculate kinetic energy of ball X before the collision. And for ball X, the speed of ball X is given and the mass of ball X is also given. Now simply we need to calculate kinetic energy. So simply we can say kinetic energy is equal to 1/2 mv squared. We have the value of mass, we have the value of the speed in this case, and simply we can plug in these values and we can calculate kinetic energy of ball X. Mass of ball X is 0.24 kgs and the speed of ball X is given, that is 2.3 meters per second, and it is square. And if we solve this one, your final answer will be 0.63 joules. We are using 2SF because this raw data also has 2SF. So our final answer in this case is 0.63 joules. This question has 3 marks. The first mark is if you have written this formula. And the second one, if you plug in values, you will get second C mark. And this is answer mark. If you got the right answer, you will get full marks. For second part, it is given to us the area enclosed by the lines and the time axis in figure 2.2 represents the change in momentum of ball Y during the collision. We need to determine the magnitude of the change in momentum of ball Y. Now, first thing we need to understand is that why this area, this is equal to change in momentum. If we look at these two balls, we have ball X, so this is ball X, and here we have ball Y. So when these two balls, they are in contact, they collide with each other, so they will exert force on each other. Means this ball X, this will exert force on Y. So this will exert force on Y by X. So this will be the force on Y, and Y will exert a force on X. So this will be the force on X. But these two forces, they will be equal in magnitude but opposite in direction. So this is a very important point we need to understand. Now if we multiply this force, as we simply understand F net, this is equal to change in momentum over time. So this is delta P over T. Now delta P from here, simply you can see that delta P simply will be equal to F times T. So that's the reason the area under this line, this is representing the change in momentum. So this is over delta P. So this is one concept you need to understand. Now simply we need to calculate area. So area in this case, this is equal to change in momentum. So simply we can say the change in momentum in this case, this is equal to area. But if you look at the shape, this is a triangle. So simply we need to calculate area of triangle, and area of triangle is simply equal to 1/2 time base, means the base of triangle, and we need to multiply this one with height of triangle. Now the first thing we need to find out the base. The base is simply equal to 5, means 5 minus 0. So simply we can say base in this case is equal to 5. But the unit of time is milliseconds. So we have to multiply with 10 to negative 3. Next one is the height. So height you can find from here. So this is the height of this triangle, and this is equal to 240 newtons. So simply we have to multiply this one with 240 newtons. Now if we simply calculate, our final answer will be 0.60 newtons second. So our final answer is, in this case, change in momentum is 0.60 Newton seconds. And this question has 2 marks, and the first mark is for this one. If you have plug in right values, you will get C mark, And the second mark is answer mark. If you got the right answer, you will get 2 marks. For this question, we need to calculate the magnitude of the velocity of ball y after the collision. But this question is a little bit tricky one, so let me explain to you. So our main focus in this case is ball y. So we have to focus on this one. For this question, we have already calculated the change in momentum. Delta P we have calculated, that was equal to 0.60 Newton second. We have already calculated this one. Now, if you look at these two balls, ball Y and ball X, this is momentum of these two balls before collision, means the momentum of this ball and momentum of this ball. And this surface is frictionless and there are no any external force, means no net external force is acting on this system. So this is our system we have defined. This is our system. And so it means that there is no change in momentum of the system, means the total momentum of the system remains constant. If you look at the momentum of this ball, the momentum of ball X, this is greater than momentum of ball Y. So the net momentum in this case, this is to the right. So the net momentum is to the right before collision. So it also means that the net momentum after it also has to be to the right. So the net momentum has to be to the right. So this is very important point. This is what you need to understand. So you can simply say that in this case, the initial momentum is to the right. So the final momentum also has to be to the right, means the final momentum of the system. So if we have understanding of this now, so when these two balls, they will collide with each other, they will be force on this ball by this ball X, and that force will be to the right. So I will simply write down the force on ball Y by X. This force will be to the right. So this ball, in fact, this will go to the right. So simply we will say the final momentum of ball Y, it will be to the right, and its initial momentum is to the left. Now question is asking us to calculate final momentum. So simply we can write down delta P in this case. This will be equal to P final minus P initial. P final is to the right, so we have to take one direction as positive. So let's say to the right is positive. If to the right is positive, so to the left, that will be negative. So now simply we need to plug in values. So here we can plug in values. Delta P, this is equal to 0.60 Newton second. So this is 0.60. Let me rewrite this one. So change in momentum we have calculated, that was equal to 0.60 Newton second. And P final we can calculate from here. So P final is positive because this is to the right and we assume to the right is positive. And P initial, this is to the left. So this will be negative. So this will be negative. And we can multiply velocity in this case with the mass. So this will be the momentum of ball Y before collision. And now simply we need to simplify this. If we simplify this one, we can simply write down this is P final and this will be plus. We have 2.3 times 0.12. We need to calculate P final. So P final from here we can say that this will be 0.60 minus 2.3 times 0.12. If you do these calculations, final answer will be 0.324 Newton second. And this is the value of the final momentum of ball Y. But now we need to calculate the final velocity of ball Y, means the velocity after collision we have to calculate. So we can simply write down final momentum. This will be equal to mv, the momentum after collision, and this is 0.324. We need to find v from here. So simply just divide by mass. So this is 0.324. We need to divide by the mass of Y, and mass of Y is 0.12. So this is simply divided by 0.12. So the final answer in this case is 2.7 meters per second, mean this ball Y will go to the right with this velocity, and this is the magnitude of that velocity. So simply our final answer has to be 2.7 meters per second. This question has 2 marks. If you have got final momentum right, you will get 1 mark, and this is C mark. And if you got right value of the velocity, you will get second mark. For part C, on figure 2.3, we need to sketch the variation with time t of the force Fx exerted on ball x by ball y during the collision in part B. First of all, let's try to imagine that what is happening. Imagine that you have this one ball, this is ball X, and this ball is colliding with another ball, and this is ball Y. So when these two balls, they will collide with each other, they will exert force on each other. So the force on Y, we can simply say the force on Y by X. There will be also another force on X by Y. So we can say this is the force on X by Y, and these two forces, they will be equal in magnitude and opposite in direction because they are action and reaction forces. So I will simply write down here Fx, this will be equal in magnitude to Fy but opposite in direction. You can also feel this one by clapping. When you clap your hands, you will feel the force on both hands, and those forces will be equal in magnitude but opposite in direction. So by clapping, you can also feel this. Now, we also need to understand the time of contact or the time they exert forces on each other. Let's say this time is Tx. For time Tx, the force is exerted on ball X by ball Y. This will be equal to the same time for ball Y as well. Means the forces will act on these two objects for the same period of time. From here, we can also say that delta P for X, the change in momentum of X will be equal to change in momentum of Y, because change in momentum is simply equal to force times time. So from here you can also say that impulse on X is also equal to, I will simply say impulse X, that will be equal to impulse Y. So impulse is also the same because impulse is also simply equal to change in momentum, or simply you can say this is equal to force times time. So you can see from here forces on two bodies are the same. Time of contact is also the same. Change in momentum for these two bodies is the same. So this is our third point. And the fourth one you also need to understand, impulse for both bodies also is the same. So very important concept. They can ask you next time in a different way. Now, this question is simply based on our first concept. Force on two objects is the same in magnitude but opposite in direction. Now simply if we go back, we have already done actually this question, because in the question it was given to you force acting on Y. So now it has to be just reflection of that force, means the reflection of that graph. So let me show you that graph again. So the first thing, you can simply imagine this is how you need to sketch this one. So this is the force on X during collision, and this is the reflection of the force on Y, because these two forces, they have the same magnitude but their direction is opposite. So let me clean first and show you the force acting on Y. So this is the force that is acting on Y. So if you look at these two graphs, now simply you can imagine that force on X is equal in magnitude to force on Y but opposite in direction. So this force here at this point is 240 newtons. So at time 3 millisecond. So here this force also has to be, you can simply write down 3 comma negative, this is 240 at this time, and here 0, so 0 comma 0, so this is 0. There is no force here. This is after collision and this is before collision, so this is also 0. So this is how you need to sketch the graph. So if you have done this one, you will get full marks. Welcome to A-Level and AP Physics. In today's lesson, we will discuss an important question on stress and Young's modulus from October-November 2021, paper 2, variant 1. In this question, we will discuss what is stress, what is Young's modulus, and what is strain energy. For this question, it is given to us a uniform metal bar initially unstretched has sides of length W, X, and Y as shown in figure 3.1. As you can see here, X is this side, Y is this side, and this side is W. It is also given to us the bar is now stretched by a tensile force F applied to the shaded ends. And question is asking us, A1 is asking us, we need to calculate the stress applied to the bar by the tensile force. Means we need to determine the stress. Let's try to understand what is stress. Stress is simply equal to the force divided by cross-sectional area of the material. So this is cross-sectional area of the material. So very important. So this is very important if the tube is hollow. So this is cross-sectional area of the material. So divided by cross-sectional area of the material. So very important point. Often in the books it is written cross-sectional area and students often get confused if the pipe is a hollow or the tube is hollow. Now how we can calculate? So what is the force in this case? So we apply force F on this. So simply we will say sigma in this case. This will be equal to F divided by cross-sectional area of the material. And this is the cross-sectional area. So this is cross-sectional area. This tube is uniform. So simply you have to divide by xy. So this is how you can calculate stress. Let's move on to second part. For the second part, question is asking us to calculate the strain in the bar. So first let's try to understand what is strain. Strain simply is equal to the change in length, means delta L. This can be extension, this can be compression, divided by L, means the original length. Now in this case we need to understand what is delta L first of all. Delta L in this case simply we need to understand, first of all we have W. So this side you can see the original, this is W. Now this become Z. So it means delta L simply is Z minus W, and this is divided by original length, that was W. So this is how you can write down strain. For the next part, question is asking us to calculate Young's modulus of the metal from which the bar is made. So we need to find out value of E. So simply we can say Young's modulus is capital E, and this is equal to stress over strain. So simply we can write down stress over strain. Stress and strain we have already calculated, so simply we can write down stress is F over xy, and this is divided by strain, and strain is Z minus W divided by W. Now if we simplify this one, so simply we can write down this will be FW. This is FW because original length is W. So this will be equal to FW divided by xy times Z minus W. So this is how you can calculate. This question has 1 mark and this is B1 mark, means this has to be in your answer. Your answer has to be like this. And the second one, this is also B1 mark, so your answer has to be this one. If you have written this one, you will get this mark. And the next one is Young's modulus, and this has 2 marks. The first mark is C1 mark. If you have written stress over strain, you will get C mark. And if you got the right answer, you will get answer mark as well. If your answer is right, still you will get 2 marks. For part D, question is asking us state the maximum extension of the wire for which it obeys Hooke's law. First of all, let's try to understand what is Hooke's law. So let me little bit write down about Hooke's law. According to Hooke's law, force means the applied force, or applied force and restoring force, they are the same. In this case, we made assumption. So restoring force is directly proportional to extension. So this is negative x, means the restoring force and extension, they are in opposite direction. So simply you can say the restoring force is directly proportional to extension. So the graph is given to us between force and extension. Now simply we need to find out until these two are directly proportional. So if we look at this one, until here, it is a straight line. So it means Hooke's law is obeyed until this point. And now we need to find out what is value of extension. And this one's directly we can read out from the graph, and this is about 2.2 millimeters. So simply for this part, we have to write down 2.2 millimeters, and this is the answer. For the second part, question is asking us to use figure 3.3 to determine the strain energy in the wire when the tensile force is 120 newtons. Means when the force is 120 newtons, we need to calculate the strain energy in the wire. First thing, strain energy. So how we can calculate strain energy? Strain energy in this case is simply equal to the area under this graph. So this is equal to area under graph. So simply we can write down this is equal to area under graph. So this is first thing we have to understand, area under graph. Now simply we need to calculate this area, and this area is area of a triangle. So area of triangle is simply 1/2 times the height of the triangle. Height of triangle in this case is 120, and the base of triangle, and base of triangle is 1.4 millimeters. So this is 1.4 millimeters. We have to convert into SI units. Now if we simplify this one, means we just do these calculations, we can calculate value of strain energy, and that will be equal to 0.084 joules. So our final answer for this one is 0.084. Now you need to understand is that strain energy is the energy stored in the wire until the wire is in elastic region. But when it is in the plastic region, then area under graph is not equal to strain energy. This question has 3 marks. The first mark you will get C mark if you have written strain energy is equal to area under graph. In this case, you can say strain energy is equal to area under graph because until this point, it is still in the elastic region. Means this wire is still in the elastic region. So that's the reason you can say strain energy is equal to area under graph. And the second mark is if you have plug in these values, these right values in the formula, then you get the second mark. And the third mark is answer mark. If you have got the right answer, you will get this mark. If your answer is wrong, but you have done these 2 steps, still you will get 2 marks. So the main takeaway from this one is strain energy is equal to area under graph as long as the wire is in elastic region. So you have to be very clear about this one. When you can calculate strain energy by calculating area under graph only when the wire is in elastic region. So as long as it is in the elastic region, you can calculate strain energy just by calculating area under graph. Strain energy you can also calculate like this. So we also call strain energy. This is called elastic potential energy, and this is also equal to 1/2 Fx. F is the force, maximum force, and x is the extension. Or you can also calculate by 1/2. So F we can replace with Kx. K is the spring constant, and this is x. So we can also write down this is 1/2 Kx squared. So you can also use this if K is given to you. Let me explain you a little bit more about strain energy because strain energy is often confusing for many students. Strain energy, in fact, is the energy stored in a wire or in a spring as long as the wire is in elastic region, or we can say until elastic limit. And this is the energy that can be recovered if we remove the force before elastic limit. So strain energy can be recovered if we remove the force. So that's the reason we call this is strain energy. For the last part, we need to explain why the work done in stretching the wire to an extension of 12 millimeter is not equal to the energy recovered when the tensile force is removed. This question is just based on the previous concept we have discussed about strain energy. Strain energy is the energy that can be recovered, and that energy means that amount of work done can only be recovered as long as the wire is in elastic region, or simply we can say until elastic limit. So amount of work done can be recovered because when we do work on the wire before elastic limit, amount of work done is stored in the wire in form of strain energy, and that work done can be recovered. But for this question, it is given to you the energy recovered. This is not equal to work done. So simply we can say that in this case the work done, this is equal to some amount of strain energy. Means when we will remove the force, some of work will be recovered plus some amount of work will not be recovered, and that becomes the internal energy of the material, and molecules go away from each other, so that amount of work done is stored in form of potential energy of molecules. So simply we can say plus internal energy. So this is one thing we need to understand: the amount of work done, it has been saved in form of strain energy in the material, and that amount of work done can be recovered. So this can be recovered. So this is, and some amount of energy or amount of work done, that becomes the internal energy of the molecules, and that cannot be recovered. And this question has 2 marks. So simply first point we can write down: wire has been deformed plastically. So we can say wire has been deformed plastically. So simply we can say that wire has been deformed plastically. So means the wire has entered plastic region, deformed plastically. So wire has entered plastic region plastically. And the second one we can say energy becomes internal energy. Some amount of work becomes internal energy of the wire or internal energy of molecules, internal energy, and this is the potential energy of molecules. This question has 2 marks. The first mark is B mark. If you have written this, you will get 1 mark, and the second is also B mark. If you have written it becomes internal energy, you can also say that some amount of work done has been converted into heat, or you can say into thermal energy, or you can say becomes thermal energy. Means energy has been dissipated in form of thermal energy. So if you write down these 2 points, you will get 2 marks. If you look at this curve, until here it is in the elastic region. So simply you can also understand this is the elastic region. So the amount of work done until this point can be recovered, but the amount of work done in this region, that cannot be recovered because this has entered plastic region. I hope it is clear to you now, and that's all what you need to understand. Welcome to A-Level and AP Physics. In today's lesson, we will discuss an important past paper question on waves and Doppler effect from October-November 2021, paper 2, variant 1. I said this question is very important because this question will help you to improve your conceptual understanding of Doppler effect. For part A, we need to state what is meant by a longitudinal wave. And in our answer, we have to mention direction of transfer of energy. The best example, or simply I can say the simplest example of longitudinal waves is sound. Sound waves are longitudinal waves. Now let's imagine that the wave is moving to the right, means the energy is transferred to the right, or you can say direction of wave is to the right. So simply we can say this is direction of energy transfer. Direction of energy transfer means the wave is moving to the right. Now we need to consider oscillations of medium particles. So if I take one medium particle, let's say this is one medium particle. And so how this medium particle will oscillate? So this medium particle will oscillate to the right and it will oscillate to the left. So this is how medium particle will be oscillating. From here simply we can say the oscillations and energy transfer, they are parallel. So this is what you need to write down. So these are oscillations. So oscillations and energy transfer, they are parallel to each other. And that's all what you need to write down for this question. So now let me show you how you can write down the answer. This is how you can write down answer. Simply you can say oscillations of particles, medium particles, they are parallel to direction of energy transfer. If you write this one, you will get 1 mark. For part B, it is given to us a vehicle travels at a constant speed around wide circular track. It continuously produces sound and the frequency of the sound is 1.2 kilohertz. There is an observer who is standing at a large distance away from the track, and this is shown in figure 4.1. So here is figure 4.1. In this figure, you can see this is the vehicle and this is traveling around circular track. An observer is standing somewhere here. Figure 4.2 shows the variation with time of the frequency f detected by the observer. It is also given to us the time taken for the vehicle to travel once, means to complete one cycle. That time is equal to capital T. So simply you can see from here, so capital T is the time taken by vehicle to complete one cycle, and 2T is the time taken to complete two cycles, and 3T is the time taken for vehicle to complete three cycles. On y-axis, this is the observed frequency. So simply we can say this is the frequency observed by observer. So this is observed frequency. Now for part B1, we need to explain why the frequency of the sound detected by the observer is sometimes above and sometimes below 1.2 kilohertz. And 1.2 kilohertz is the frequency of the sound produced by source. Observed frequency, it is given to us, it is sometimes higher than the frequency of the sound produced by source. It is also given to us sometimes observed frequency. This is lower than frequency of the sound produced by source. Now we need to understand why sometimes it is lower and why sometimes it is higher. And that is only possible if there is a relative motion between source and observer. Means there is relative motion between source and observer. So this is the first point we need to understand. Next, we need to understand when the observed frequency is higher than the frequency of the sound produced by a source. Observed frequency will be higher than frequency of the sound produced by source when the source is approaching observer. In this case, our assumption is that observer is not moving. So when the source is approaching, observed frequency will be higher than the frequency of sound produced by source. And the second, observed frequency will be lower than frequency of the source when the source is moving away from observer. So when the source is moving away. And this is due to Doppler effect. Now you see, if you look at this question has 2 marks. So is asking you to explain why. So one thing you can explain, when there is a relative motion between source and observer, we will perceive observed frequency higher or lower than the frequency of the sound produced by source. Next, you need to explain when it will be higher if the source is approaching, and it will be lower when the source is moving away from observer. So these 2 points simply you have to write down to get 2 marks. And the next part is asking you state the name of the phenomenon in part B1, and that is simply Doppler effect. So if you write down Doppler effect here, you will get 1 mark. So now let's try to understand how we can write down the answer for this question. So this is how you can write down the answer. This is all what you need to write down. I have mentioned all these points here. Frequency varies as vehicle moves relative to stationary observer, means when there is a relative motion, and frequency is higher than the frequency of the source when the source is moving towards observer, and when the source is moving away, observed frequency is lower than the frequency of the sound produced by source. So if you write down these points, you will get 2 marks. And the next one is a B mark. Simply you need to write down Doppler effect and you will get 1 mark. I hope it is clear to you now. For third part on figure 4.1, we need to mark with the letter X the position of the vehicle when it emitted the sound that is detected at time t. So we need to go back to figure 4.2. If you look at figure 4.2, so this is the time. And at this point, the observed frequency, so this is observed frequency on y-axis. Observed frequency is maximum, and this is greater than frequency of the sound produced by source. So first thing we need to write write down here that observed frequency, this is greater than frequency of the source, and observed frequency, this is maximum, and so this one is maximum. So if the observed frequency is maximum and this is greater than the frequency of the source produced, it simply means that the source is moving towards observer directly, moving towards observer and directly moving towards observer, because this is maximum. So that's the reason we have to mark X here. So vehicle is at this point at time t. Now let's move on to next one. On figure 4.1, mark with the letter Y the position of the vehicle when it emitted the sound that is detected at time 9t by 4. Now if you look at this one, this is t by 4. So this is 1t by 4. So this will be t by 2 means 2t by 4. And here 3t by 4. So here we will have 4t by 4, and here we will have 5t by 4, here we will have 6t by 4, here we will have 7t by 4, here we will have 8t by 4, and here we will have 9t by 4. Now if you look at this point, at this time, the frequency, observed frequency, this is equal to frequency of the sound produced by source. So simply we can say at this time observed frequency is equal to the frequency of the sound produced by source. Now question is asking us to mark that position. So that is possible when the vehicle is here. So in this case you can see if you combine source and observer by this line, you can see the angle between them is 90 degrees. It simply means that there is no relative motion between source and observer. So simply we can write down here no relative motion, and so there is no relative motion between source and observer. So it means vehicle is at this point. Vehicle is at this point. You can also understand why this is not. If you look at this point, for example, so you can also join this one. You see, when the vehicle is moving this way, the angle between source and observer is also 90 degrees, and there is no relative motion. So at this point, observed frequency, this also will be equal to frequency of the source. So here is also no relative motion. Observed frequency is equal to frequency of the sound produced by source. Now why is this point? If you look at this now, after 1t, so after 1t, the source is here. After 2t, source is again at this point. So you see, after 2t, source is here. It means the vehicle is here. So after t by 4, vehicle will be here, not here. So that's the reason you have to mark Y here. And this one has B mark, 1 mark. If you have marked X here, you will get 1 mark. And this also has 1 B mark. If you write down simply Y here, you will get the second B mark. For part C, it is given to us the speed of the sound in air is 320 meters per second. We need to use figure 4.2 to determine the speed of the vehicle in B. So simply question is asking us what is speed of this vehicle. For that purpose, we have to use Doppler effect equation. And Doppler effect equation is given in your formula list if you didn't remember. So Doppler effect equation, simply in the formula list, it will be given like this: V over V plus minus Vs. Vs is the speed of source, and here this is the frequency of the sound produced by source. In this question, we need to calculate Vs. So we have two options. We can take minimum frequency, or we can take the maximum frequency. Means when the source is approaching or when the source is moving away. I will take when the source is approaching. So I will be using F naught is equal to V over V minus Vs. When the source is approaching, I will be using V minus Vs, Fs. So this is the frequency of the sound produced by source. Now simply we need to understand when the frequency is maximum. Frequency is maximum when the source is directly approaching, and that value we have F observe is equal to 1.4 kilohertz. So we can simply write on 1.4 kilohertz. And frequency of the source is given in the question, that was equal to 1.2 kilohertz. You can also read from here. So this is 1.2. So this is 1.2 kilohertz. Speed of sound is given, that is equal to 320 meters per second. Now simply we need to plug in values and we can calculate Vs. So let me plug in these values. So F naught, we have this is equal to 1.4 kilohertz. So this is F naught, and the V is speed of sound, and this is divided by speed of sound minus speed of vehicle. This is what we need to find out, and this is multiplied with frequency of source, and frequency of the source is 1.2 times 10 to 3. And now simply we can find out Vs from here. Vs will be equal to 46 meters per second. So this is our final answer. This question has 3 marks. So here you can see this question has 3 marks. The first mark you will get if you have written this one. You are using the maximum observed frequency or minimum observed frequency, you will get 1 mark. And the second mark is that if you are using this right Doppler effect equation when the source is approaching or when the source is moving away, you will get the second C mark. And the final mark is answer mark. You will get this mark if you got the right answer. Now let me help you a little bit how to rearrange this formula. So maybe some students, they're not clear how to rearrange. So let me a little bit help you with this formula, how to rearrange to get Vs. The simple way to do this one is you can multiply here. So F naught here, we can multiply, cross multiply. So you will get F naught times V minus Vs. And this will be equal to V times Fs. Now we need Vs. So we can divide by F naught on both sides. Means you can divide by F naught here. So you will also divide by F naught here. So we can cancel this one here. So we left with V minus Vs. And this will be equal to V times Fs divided by F naught. We need Vs now. So if we move this Vs, so let me write down here. So V minus Vs, so you can add Vs here. So you have to add Vs on other side as well. So this is Vfs divided by F naught. So we have Vs here. So you can see Vs plus minus we can cancel. Now we have Vs here, but this is Vfs, F naught is here. We can move this one to the left. So what I'm saying is that V minus, and here you have Vf naught, Fs, this is divided by F naught. You can minus Vfs over F naught here. So you also have to minus here. So you will write down Vfs divided by F naught here, and plus Vs we have already here. Now you can see this is negative, this positive cancels. So the Vs finally will be equal to V, this is the speed of sound, minus speed of sound times frequency of the source, means the frequency of sound produced by source divided by observed frequency. So in this formula you can plug in values if you don't know how to calculate from here. So you can just simply plug in values in this one. Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on electricity from October-November 2021, Paper 2, Variant 1. This is a typical type of question because this type of questions are very common in past papers. For part A, simply we need to state what is Kirchhoff's first law. Kirchhoff's first law, Kirchhoff's second law, these are very common type of questions you will see in many past papers. Sometimes they will ask you to state what is Kirchhoff's first law. Sometimes they will ask you to state what is Kirchhoff's second law. So you have to be very clear about these two laws. Now let's try to understand what is Kirchhoff's first law. Kirchhoff's first law simply we can understand with one very simple circuit. So let me draw one simple circuit here. Let's say we have this circuit, and in this circuit we have one battery, or simply you can say one cell and two resistors that are connected in parallel. Kirchhoff's Kirchhoff's first law simply tells us, let's say current coming from the battery is I at this junction. This point is called junction, or you can say this is node. So current will split into two parts. Let's say current I1 go through this resistor. Let's say this is resistor 1 and this is resistor 2. And current I2, this will go through the second resistor. Now Kirchhoff's first law simply tells us that current entering means I entering. This junction has to be equal to I leaving. So simply we can say I entering, this has to be equal to I leaving. I entering in this case, this is equal to I, and I leaving, this is equal to I1 and I2, means I1 plus I2. And this is what Kirchhoff's first law tells us. So simply this is what you need to understand. Now we need to understand how we can write down our answer. In order to write down the answer, simply you can say at any junction. Simply you can say at any junction. So this is one point you have to mention. At any junction in a circuit, we can say in a circuit, I entering has to be equal to I leaving. That's all what you need to write down. I entering has to be equal to I leaving. So if you write down these 2 points, you will get 2 marks. But for this question, I entering is equal to I leaving. This has to be in your answer because this has M mark. So if you write down this one, you will get this mark. And the second mark is for this one, and this is A mark. So you must get M mark to get A mark. So it has to be in your answer. If you didn't write this one, if you mention this part, still you will not get any mark. Now let's try to write down complete answer. This is how you can write down a full answer for this question in a proper way. So this is at any junction in a circuit. So this has 1 mark, this is A mark, and the second mark is M mark. So if you write down sum of currents entering is equal to sum of currents leaving, so you will get M mark, and this is A mark. You must get M mark to get A mark. If you can't get this mark, even you have written this part, still you will get 0 mark. So this is very important. For part B, it is given to us the circuit shown in figure 5.1. It contains a battery of electromotive force capital E and negligible internal resistance. Means internal resistance of this battery, this is equal to 0. We can assume this is equal to 0. And it is also given to us there are 4 resistors, and all these resistors, they have the same resistance. So it simply tells us that all the resistors in this circuit, they are identical resistors. So simply we can write down all the resistors are identical resistors because they have the same resistance. Now let's say current I1 is coming from the battery, and this current will pass through this resistor. And let's say current I2, this is passing through the second resistor, and current I3, this is passing through this resistor. And current I4 is passing through resistor 4. We can simply say this is I4. And this is the current entering the battery as well. Now let's connect voltmeter across this second resistor. So we can connect our voltmeter here between these 2 points. We can also connect another voltmeter across this resistor. Let's say this is another voltmeter, and this is connected between these 2 points. Now we need to understand, as this is connected at this point, so the potential at this point and potential at this point is the same, because there is just ideal wire between these 2 points. There is no any other circuit component connected here. So this point, they are at the same potential. If we look at these 2 points, this point, they are also at the same potential because there is just ideal wire, and ideal wire has no resistance. So if the reading of this voltmeter is V2 and the reading of this voltmeter is V3, so simply we can say in this case V2 will be equal to V3. V2 we can also write down V2 is equal to I2 times R, because R2 is equal to R, and R3 this is also equal to R as it is given in this question. We can also write down V3, this will be equal to I3 times R. Now R is common on both sides, we can simply cancel. We can say I2, this will be equal to I3, and I3 is given in this question, so that is equal to 0.30 amps. So I2 is also equal to 0.30 amps. Now from here we can write down I1. I1 is equal to I2 plus I3 according to Kirchhoff's first law. So simply we can say I1, this will be equal to 0.60. Now what is value of I4? I4 also has to be equal to I1 because current entering the battery and leaving the battery is the same, or simply you can understand from here I2 is entering this junction and I3 is also entering this junction. So the I4 is leaving this junction. So this will be equal to I2 plus I3. So I4 is also equal to 0.60 amps. Now question is asking us to calculate resistance. So across this resistor, value of potential difference is given, that is equal to 2.4 volts. So this is 2.4 volts, and current passing through this one we have, this is 0.60. So simply we can write down R will be equal to V4. This will be divided by I4. So the V4 is 2.4 volts and I4 means current passing through this resistor. This is equal to 0.60 amps. So our final answer in this case will be equal to 4.0 ohms. That's what question was asking us to show that. So this is our final answer. This question has 2 marks, and the first mark is if you have got this value of I, and this is B mark. So you will get B mark if you have got I4 is equal to 0.60 amps, and the second mark is answer mark if you have got right value of resistance. So you will get 2 marks. For second part, we need to determine the EMF of the battery. And EMF of the battery, we can determine using different methods. We can use Kirchhoff's second law, or simply we can use Ohm's law. For this question, I will be using simply Ohm's law. In order to use Ohm's law, we need to calculate the total resistance of this circuit. So first of all, let's try to calculate what is the total resistance of these two resistors. The resistance of each resistor, this is equal to 4 ohms. We have just calculated in the previous part. So simply we can write down this is 4 ohms. And as these two resistors, they are connected in parallel. So the total resistance of these two resistors simply will be equal to the resistance of one resistor divided by number of resistors. We have 2 resistors, so simply we can divide by 2. So the total resistance of these 2 resistors is simply equal to 2 ohms. Now this circuit we can redraw. So this is our battery, so we can draw, this is battery is here. We have one resistor, this is R1 resistor, and these 2 resistors we can simply replace with one resistor. Here we have resistor 4 that is connected here. So this is our new circuit. Resistance of this one R1, this is equal to 4 ohms. This resistance is also equal to 4 ohms. But this resistance of these two resistors, this is equal to 2 ohms. Now the total resistance, these 3 resistors, they are connected in series. So the total resistance is simply sum of these resistors. So our total for this circuit, that will be equal to 4 plus 4 plus 2. So simply this is equal to 10 ohms. So this is total resistance of the circuit. And current in the circuit we have already calculated. I1, this was equal to 0.60, and this is the current passing through the battery. Now we need to calculate EMF, so simply we can say EMF, this is equal to I total, means current passing through the battery, times the total resistance of the circuit. Total current passing through the battery is equal to 0.60 amps, and total resistance of the circuit, this is equal to 10 ohms. So simply this is equal to 6.0 volt, and this is EMF of this battery. This question has 2 marks, and the first mark is if you have calculated this total resistance, so this one will be the C mark, and the second mark is if you have got the right answer, and this one is answer mark. For part C, it is given to us the battery in B is replaced with another battery of the same EMF but with an internal resistance that is not negligible. It simply means that battery has internal resistance now, and we cannot ignore this internal resistance. So simply we can say this is small r. And this is all inside the battery. So this is our battery now. And this battery has internal resistance. So this is our battery and this is internal resistance. This is resistance of the battery itself. So that's the reason we call this is internal resistance. Sometimes we also call this is source resistance. Now question is asking us, state and explain the change, if any, in the total power produced by the battery. Now we need to state and explain if there is any change in the total power produced by the battery. So in order to answer this question, first thing we need to consider is that, is the total resistance of the circuit, is it increasing or decreasing? We have already calculated total resistance of the circuit, that was equal to 10 ohms. But now you can see here we have another resistance that is connected in series. So it means the total resistance of the circuit is increasing. Total resistance of the circuit increase, so total current in the circuit means I total in the circuit, this will go down, so this will decrease. So these are 2 points we need to understand. First, total resistance of the circuit will increase and total current in the circuit will decrease. Next thing we need to understand the power. So we can say the P produced by the battery. So P by battery we can write down. So power produced by the battery, this will be equal to EMF of the battery, V square divided by R, and R is the total resistance. Now you see EMF of the battery is the same, but the total resistance has been increased. So it simply means that the power produced by the battery decreases. So these points simply we need to write down. So let me show you how you can write a proper answer. This is how you can write down a proper answer. So this question has 2 marks. You will get first mark, B mark, if you have written total resistance of the circuit increases. And you will get the second mark if you have written total current decreases. So the total power decreases. So this is how we can answer. Simply we can say battery will provide less energy per second to the circuit. So total power decreases. Total power produced by the battery will decrease because some of the energy, electrical energy produced by the battery will be converted into thermal energy inside battery due to its internal resistance. So that's the reason total power decreases. For the last part, it is given to us the resistors in the circuit of figure 5.1 are made from nichrome wire of uniform radius 240 micrometers. The length of this wire needed to make each resistor means one resistor is 0.67 meter. We need to calculate resistivity of nichrome. So simply we can start from here. R is equal to rho L by A. We need to calculate resistivity, so simply we can rearrange this one. So we can write down this is RA divided by L. A is the cross-sectional area of the wire. So simply we can write down this is cross-sectional area of the wire divided by L, the length of the wire. Now simply we need to plug in values. So resistance of each resistor we have already calculated. That was equal to 4.0 ohms. Now we simply need to multiply pi with radius of the wire. Radius of the wire is given, this is 240 micrometers. So this is 10 to negative 6. Square of this one, so we have to take square of the radius. We have to divide by L. L of each resistor means the length of wire for each resistor is given, that is 0.67 meters. Now simply we need to calculate and we can get value of resistivity for nichrome. In this case, our final answer will be 1.1 times 10 to negative 6 ohms meter, and this is our final answer. This question has 3 marks. The first mark is, if you have written formula in this form, you will get C1 mark. And the second mark is if you have plugged in right values. And the last one is A mark. If you have got the right answer, you will get full marks. Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on radioactivity from October-November 2021, Paper 2, Variant 1. This is a typical type of question because you will see this type of questions very often in past papers. For part A, we need to complete table 6.1 to show the masses in terms of atomic mass unit U and charge is in terms of elementary charge E of alpha, beta plus and beta minus particles. First of all, let's try to understand these particles. Alpha particle, first of all, simply this is helium nucleus. So we can write down alpha particle is equal to helium nucleus. So as it is helium nucleus, it means it has no electrons. So helium nucleus is very important. Sometimes in exam they will ask you what is alpha particle. So simply you can say is helium nucleus. And the symbol for alpha particle is alpha, and this is atomic number of this one is 2 and the mass number of this one is 4. In some books you will also see this symbol for alpha particle. Now we need to understand alpha particle, its atomic number is 2. So it means that the number of protons it has, that is equal to 2. Mean it has simply 2 protons and it has 2 neutrons. We can say number of neutrons. So alpha particle consists of 2 protons and 2 neutrons. Now we need to understand what is the charge on alpha particle, and charge on alpha particle is equal to the charge on 2 protons. Protons and electron, they have the same charge but their sign is opposite. So simply we can say the charge on alpha particle is plus 2e. And next question is asking us about the mass of alpha particle. Alpha particle consists of 2 neutrons and 2 protons. Mass of proton is about equal to the mass of neutron, and the mass of proton or mass of neutron is almost equal to 1u. So simply we can say as it consists of 2 protons, 2 neutrons, so the mass of alpha particle is equal to 4u. That's all what we need to write down for alpha particle. So simply we can write down 4 here because unit is already given and the charge on alpha particle is plus 2. That's all what we need to write down. Let's move on to beta particle. Beta particle, in fact, this is electron. So simply we can write down beta particle is electron. And the mass of electron is this one. So this is mass of electron. And the charge on electron is simply, this is minus 1e. So this is charge on electron. Next one is beta plus particle. Beta plus particle, in fact, this is antiparticle of electron. So simply we can write down here, this is antiparticle of electron. Antiparticle of electron, we also call this one, this is positron. So beta plus particle also we call this is positron. So as this is antiparticle, so the mass of beta plus is the same as mass of electron. So we can say the mass of beta plus particle is the same as mass of electron. So this is 9.11 times 10 to negative 31 kgs. But this is antiparticle, so the charge on this one is opposite to electron. So it has plus 1e charge, mean it has opposite charge. So this is what we need to understand about beta plus and beta minus particle. For example, charge on beta plus is simply plus 1e and the charge on electron is minus 1. So simply we can write down here. Now we need to write down this mass in terms of u. So the mass we have in kgs and 1u is also given. This is given in data actually. You can check this one in data table. So now we need to convert kgs into u. So simply we can write down mass in kgs divided by mass in u, means 1u is equal to how many kgs, and 1u is equal to 1.66 times 10 to negative 27 kgs per u. So if you do this division, your final answer will be 0.005 u, because you can see kg cancel, so we got u. So the mass of beta plus particle is simply 0.005. Mass of beta minus particle is also the same because they're particle and antiparticle. And that's all what we need to write down. If you write down all these right, you will get 4 marks. So this question has 4 marks. For part B, it is given to us carbon-14 is radioactive and decays by emission of beta minus particles. nuclei do not contain beta minus particles. It simply means that there is no electron in the nucleus. We need to explain the origin of beta minus particle that is emitted from the nucleus during beta minus decay. So this question is simply about beta minus decay. If we understand what is beta minus decay, then we can answer this question. So let's try to understand first of all what is beta minus decay. Let's say we have nucleus X, it has atomic number Z and it has mass number A. It decays by beta minus decay. So it will form another nucleus. It will also emit beta minus particle and also one electron anti-neutrino, because this is particle, so this has to be anti-particle to conserve lepton number. Now from here you can simply understand. So the atomic number of this new nucleus, this has to be Z plus 1 and its mass number will stay same. Now if you look at this one, you can see the proton number increases by 1. So it simply means that one neutron, it becomes proton, and also there is one beta minus particle, or simply you can say this is electron. So that's the reason one neutron changes to proton and also it emits one electron. So that's the reason when this nucleus, this decays into nucleus Y, beta minus particle is emitted, because neutron decays into proton and electron. So simply here we can write down neutron decays into proton and electron, decays into proton and electron. So simply this is what you need to write down, into proton and an electron. So that's the reason when this nucleus will decay, it will emit beta minus particle, mean electron will be emitted. And this question has only 1 mark, B mark. If you write down this one, you will get this mark. For the second part, we need to state the change in the quark composition of carbon-14 nucleus when it emits beta minus particle. But we have already discussed in beta minus decay, neutron decays into proton. Simply we can write down neutron decays into proton. Neutron consists of one up quark and it consists of two down quarks. Proton, it consists of two up quarks and one down quark. So simply from here we can see that one down quark, it decays into one up quark. So for this question, simply you can write down one down quark decays into a quark. So if you write down this one, you will get 1 mark, and that is B mark. Simply you have to write down this. For the last part, question is asking us to suggest why the beta minus particles are emitted with a range of different energies. Let's try to understand this one with the help of nuclear decay, means beta minus decay. Let's say we have nucleus X. It decays into nucleus Y by emitting beta minus particle and electron anti-neutrino. Atomic number of this nucleus will be Z plus 1, because this is beta minus decay, and the mass number of this one will be A. Now our main focus has to be on these two particles in order to understand why the beta minus particle, it has a range of energies. Let's say the total energy of these two particles, I will simply write on here. Let's say the total energy of these two particles is 100 mega electron volt in one nuclear reaction, or in one nuclear decay, or simply we can say in this nuclear decay. So the energy of this beta minus particle, this can be 40 mega electron volt. If the energy of this one is 40 mega electron volt, so the energy of electron anti-neutrino, this one will be 60 mega electron volt. If the energy of this electron anti-neutrino is 70 mega electron volt, then the energy of this one will be 30 mega electron volt. If the energy of this one is 80 mega electron volt. Let's say this is 80. So the energy of beta minus particle, this will be 20 mega electron volt. So it's simply, this is telling us is that the energy is shared between these two particles. Energy of electron antineutrino is more than the 50% most of the time, and the energy of beta minus particle will be less than 50% of the total energy of these particles. Now let me explain to you how you can write down answer for this question. So this is how you can write down the answer. In this answer, you can see I have mentioned electrons, neutrinos are immediate. If you write down this 1 point, you will get 1 mark, and this is B mark. Mean it has to be in your answer. And the second mark you will get if you have mentioned energy released in decay is shared between anti-neutrino and beta minus particle, means energy is shared between these two particles. So that's reason this beta minus particle or this electron anti-neutrino, they have a range of energies. And this was also the reason behind discovery of neutrinos. So this was the reason behind discovery of neutrinos, because when scientists they did different experiments, they found out this beta particle, it has a range of energy. So then they started to look for another particle that has the missing energy, and then finally we found out there is another particle, and that particle was named neutrino because neutrino has no charge.